measure at a particular point in time. So what we do, we measure temperature in a range. Okay. So now, based on the characteristics of data, probability density or distribution is attached to it. Okay. So meaning that, so I told you that data is of two kinds. One is discrete and the other is continuous. If there will be a discrete, every data, say for example, there is a data. So every data is what? Data is a random variable. What is random variable? Uh, uh, Random variable is a outcome of random experiment. Or what is random experiment? Random experiment is an experiment which outcome is unknown. Okay. Say for example, if you throw a die, so 1 will come, 2 will come, 3 will come, 4 will come. Everything is uncertain. So okay, throwing a die is a random experiment. Okay, and whatever value you get on a die, that is a random variable. Okay, so in statistics, the data is associated with randomness. Okay, so if anything in this world which is associated with randomness, and if we collect data for it, so what will happen? It will be attached to a certain probability. And if you plot that probability, so what you will do, probability and its corresponding value, you will get what we call distribution. Okay, you will get distribution. You might have seen a bell kind of distribution, which is more often, like known to everyone. So you will get a distribution. Okay, so if the data is a discrete, you will get a probability mass function. Okay, or probability distribution function. On the other hand, if data is continuous, you will get probability density function. Okay, so what we started with data is a random variable. Data is of two types based upon the nature, that is discrete and continuous. And every data, whether it is discrete or continuous, it is attached to a probability distribution. Okay, probability distribution. If the data is continuous, it will have a probability density function. If the data will be discrete, it will have probability distribution function. If the data is discrete, we get probability distribution function. On the other side, if the data is continuous, we get probability distribution function. Now you have got probability density and probability distribution. We also call, in place of probability density, we can use PMF also, that is probability mass function. Okay, so we have probability density function and probability distribution function, and in order to know the characteristics of this probability distribution or density, we take help of the moments. Okay, that is moments. This moments can be sample, or this movement can be of population. Okay, and in social sciences, okay, so this about probability mass function and probability density function. So I will repeat once again. So I have started with what? I have started with data. Okay, every data is attached with certain what we call probability. Okay, so anything which will have probability, that will have what we call distribution, right? Anything which have probability, it will have distribution. If the data is continuous, we will have probability density function. If the data is discrete, we will have probability distribution function. So in case of discrete variable, we will have distribution function. In case of continuous variable, we will have density function. Okay, so now you have got probability distribution. Now, in order to know the characteristics of this probability distribution, we take help of the moments. Okay, so the first moment of the distribution of any random variable or data is called mean. What it is called? The first moment, the first moment of a probability distribution, the first moment of a probability distribution or density is called mean. Second moment is called variance, and third moment is called skewness, and fourth moment is called kurtosis. Okay, so these are the moments. Basically, moment tells about the characteristics of probability distribution or density. if you are dealing with probability mass function, what you will do, you will see, like the that moment. Okay, if you are dealing with continuous random variable, so what you will do in case of continuous random variable, you will be basically interested into the moment of probability density function. In case of discrete, you will be interested in the moments of probability distribution function. Okay, so this is about, okay, you have seen the bell kind of distribution. Okay, so any data can take any type of distribution, but in statistics we are studying only like few distribution, okay, which is very well known distribution. And in social sciences, business and economics, four more frequently occurring distribution are normal distribution, student t distribution, chi-square distribution, and f distribution. Okay, so what it implies, that the people who deals in social sciences or business or economics, so what happened, these people more frequently, like they encounter normal distribution, t distribution, chi-square distribution, f distribution. Say for example, if you are a researcher in economics, if you are a researcher in business or social sciences, that is in maximum cases, the data, the kind of data with which you will encounter, it will fall under this four category. Either it will be normal distribution or t distribution, chi-square distribution, or f distribution. So that is why what happens in statistics also, what we do, we only study about these four kind of distribution in statistics, business, and social sciences. Okay, so now if we see the broad discipline of statistics, we can divide this broad discipline of statistics into two parts. Okay, one is the descriptive statistics, and the second is inferential statistics. So what we do in descriptive statistics, we try to analyze the characteristics of data. So how we will analyze characteristics of data? Every data is a random variable. Every random variable is attached to a probability distribution, and every probability distribution or density, it have its moments. And with the help of moments, what we do, we try to analyze the characteristics of that particular distribution, and that particular distribution only gives an idea about this. The voice is echoing, I guess. Hello. Yeah, now it's okay. So therefore, what we do. Hello. Then what we do, in the descriptive statistics, what we do, every data is attached to a probability distribution or density, and in order to know the characteristics of density or distribution, what we do, we go on to its moments. The first moment is called mean, second moment is called variance, third moment is called skewness, and fourth moment is called kurtosis. Mean is what? Mean is a measure of location. Where is the central tendency of data? Where is the maximum value is is concentrated in the data. Variance is basically telling the scatteredness of the data, how much there is dispersion in the data. Skewness basically tells about that the data is basically, it is echoing, I guess, Hello.
Sir, it's echoing, sir.
Okay. The thing is, skewness basically tells about the symmetry, whether the data is like rightward skewed or leftward skewed. And kurtosis basically tells about the peakedness, like how much there is peak in the data. Okay, so this is about descriptive statistics. In the descriptive statistics, okay, again it is echoing. It is echoing. Hello. Okay, now.
Hello, sir.
Now it's okay. Now it's okay. Okay.
Technical problems sometimes.
Yeah. No, it's okay. It's okay. No problem. The thing is, when it's echoes, it disturbs. Okay. So descriptive statistics, in the descriptive statistics, what we do, we basically study about the characteristics of data, and that characteristics of data we study with the help of probability, density or distribution, and the characteristics of density or distribution we basically analyze with the help of moments, that is mean, variance, skewness, and kurtosis. Okay. So one more thing I want to tell you, that in statistics, you might have, like more often heard the name of sample and population. Okay. So we know that sample, what is sample and what is population. Okay. Say for example, if there is a class of 50 people, okay, and if you want to arrive at a decision that a teacher will take exam on coming Monday or not, he have, like two options. One option is that census method. What he can do census of whole population, whole 50 population, and he can ask everybody in the class that on Monday there will be exam or not. Okay, so he can go to every student, or he can call every student that you stand up and tell your view that on Monday we should take exam or not. The second way is that he can ask 10 people from 50 class, and he can ask, like question to them, and on the basis of that question, their answer, he can generalize the decision on the whole population. Okay. So what happens, why we go for sample, like reduces our effort. Surveying whole population is a cumbersome exercise. It takes lots of money, lots of time. And in social sciences, business, economics, what we do, we generally don't go to whole population. We take help of the sample. And with the sample, like what we do, with the help of sample, we calculate sample statistic, and we try to infer about population parameter. Okay. So whether it is a discrete random variable or it is a continuous random variable, all the random variable, whether it may be discrete or continuous random variable, everybody will have its population and sample counterpart. Population is not observable. So what we will do, we will take help of the sample. So sample will have its sample PDF, sample CDF, sample will have its sample moments, population will have its population moment. So what we will do, with the help of sample mean, we will try to infer about the population mean. With the help of sample variance, we will try to infer about population variance. With the help of sample skewness, we will infer about population skewness. With the help of sample kurtosis, we will try to infer about population kurtosis. So now it was about the first part of statistics, which is known as descriptive statistics. Now we will move to statistical inference, which is called inferential statistics also. In the second part of statistics, that is inferential statistics. Okay. So in the inferential statistics, that inferential statistics is also divided into two parts. The first part is estimation of parameter. Okay. So how to estimate a parameter? Okay. Say for example, if you want to calculate a mean is what? Mean is a value by which what you will come to know about, you will arrive at a what we call measure of location of any particular distribution. So estimation of parameter is one part of statistical inference, and the second part is that inference about hypothesis testing about the parameter which you have estimated. Okay. So in layman terms, in journal language, what we can say, estimation of parameter is nothing but it is a formula. It is a formula by which we can, what we call arrived at what we call parameters, population parameter. Estimation of parameter. Like in this, what we do, we give a formula. Okay. So in estimation of parameter, what we do, we give a estimator by which we estimate a parameter. So every estimator, every best estimator, it have like few property. The first property is it should be linear, it should be unbiased, it have minimum variance, it should have it should be efficient, it should be blue, that is best linear unbiased estimator. If this all property meets, it will be blue. And lastly, it should be consistent. Okay. So what happens, say for example, if you have developed a what we call estimator. So estimator is a formula, and with the help of estimator you will arrive at a particular value of parameter. But whatever particular value of parameter you will arrive at, it will be a point estimator. It will give you a single value. Now the question arises whether with that particular single value you can generalize on whole population or not. So what we do, we come to the next step of hypothesis testing. Or in hypothesis testing, what we do, we take help of the statistical distribution. As I told you earlier, in statistics, in economics, in business or social sciences, more frequently we encounter four kinds of distribution. That is normal distribution, T distribution, chi-square distribution, and the last one is F distribution. Okay. So what happens? So based on the nature of data, what we do, we try to develop a interval. Okay, so interval, and in that what we do, we try to develop the interval estimate, and then with the help of hypothesis testing, what we see that whatever point estimate we have estimated, that falls under that particular interval or not. Okay, so that is that we do with the null hypothesis and alternative hypothesis. I think I am clear. So before jumping into the topic of today's discussion, so now I will try to sum up the overview of statistics, what I have told you so far, that the statistics basically deals about analysis of data on the nature, on the basis of nature. Data is divided into two parts. That is, one is discrete and this other one is continuous. Discrete data you can measure at any particular point at time, but in case of continuous data, what you have to do, you can measure that at a particular time, at an interval. You can't measure at a particular time. It's because, say for example, if you have to calculate probability, so if you throw a die, so what will be the probability of coming 1 on a die? That will be 1/6, you know, and that is a probability mass function. But if I ask you what will be the probability of a person in this world which have exactly 5 feet height, that is impossible to calculate. You will say, you know, there are people, you know, like which will be having 5 feet height. But the point is, the person which have exact 5 feet height will be very small, very negligible of total population. And we know that what is probability? What we do? Sample space by the event which is likely to occur by the whole sample space. So what we do? So what you will do, if you will calculate probability by that formula, so what you will find that the person with which have 5 feet exact height, that height will be of very, you know, like there will be very, you know, like less chances of getting person exactly of 5 feet height. Okay, so based upon the nature of data, whether it is discrete data or continuous data, what you will have probability density or distribution. If the data is discrete, you will have probability mass function, or it is also called probability distribution function. If the data is continuous, we will have probability density function. Okay, so in order to analyze the characteristics, of probability distribution, okay, whether it is probability distribution function or density function, what we do, we take help of the moments. Okay, and that moment is only called mean, variance, skewness, and kurtosis. Okay, the first moment is called mean, second moment is called variance, third moment is called skewness, and fourth moment is called kurtosis. Next, statistics, the discipline of statistics is broadly divided into two parts, that is descriptive statistics and inferential statistics. In the descriptive statistics, what we do, we try to analyze the characteristics of probability distribution or probability distribution or density, and that we do with the help of mean, variance, skewness, and kurtosis. So what we can say in short, in the descriptive statistics, we study about the sample or population movements. We try to study about the movements. And in the inferential statistics, what we do, we estimate parameters. Okay. So first of all, what is our job? First, to give a estimator. Estimator is a what? Estimator is a formula. Okay. And which will be the best estimator, which will follow the property of linearity, unbiasedness, minimum variance, efficiency, blue, consistency. Okay. And as we know that with the help of any estimator is a formula, and if we calculate any estimate with the help of estimator, it will give a particular value of that particular parameter, and that particular value will be a point estimator. Okay, a single estimator or point estimator, it can't be generalized on whole population. So what we do, with the help of theoretical distribution, statistical distribution, and with the help of based upon the nature of data, we will choose the distribution. Say for example, if the data will be close to t distribution, we will follow t distribution. If it will be close to normal distribution, we will follow normal distribution. We will construct confidence interval, and we will construct interval estimate for estimator, and we will see that whatever point estimate we have measured, that falls into that particular interval or not. If it falls under that interval, we will say that whatever point estimate we have got, that is correct. Okay, and that we do with the help of hypothesis testing. I think here I am clear. Here I am clear. Any question? Any question so far? Any question? Any doubt?
Sir, after a session, there will a question session will be there.
Okay, fine. Okay, now today's topic, okay, and for which we were waiting, but I thought, a statistical foundation is very necessary, and idea is very important to know about the econometrics. So now the question is, what is econometrics? Now, econometric deals with the measurement of economic relations. Okay. So whether it is a consumption function, whether it is a demand function, whatever economic relationship it is associated with the measurement of that particular relationship. It is an integration of economics, mathematical economics, and statistics with an objective to provide numerical value to the parameters of economic relationship. Okay. So say for example, if we talk about consumption function, okay. What is consumption function? That consumption depends upon what? So if we economic student might be knowing, for general, non-economic student, I may, I should tell you that consumption function, that consumption depends upon what? There are many theories, like that is current income hypothesis, relative income hypothesis, okay. And we have permanent income hypothesis. So Keynes have given, John Maynard Keynes, he have given current income hypothesis. So what current income hypothesis says, that consumption of any period T is function of its current income. Okay. So say for example, whatever I will consume in the month of August 2020, it will be function of whatever I earn in this month. Okay. So if I don't earn much money in this month, my consumption also will be not too high. Okay. So what happens, what we do, we, with the help of mathematics, we give a mathematical formulation to it. So what we do, the simple mathematical formulation is what? We can give a linear formulation where we can say, if CT is a consumption, we can say consumption CT equal to A plus B YT. Okay. A plus B YT means what? A will be intercept, B will be slope parameter, and YT will be income. Okay. So what we have done, we have given two parameters to consumption function. And what are those two parameters, A and B? Okay. So in theoretical economics, in theoretical economics, we give parameter, but we don't empirically estimate it. But econometrics, like as a discipline, with the help of mathematical statistics and mathematics and statistics, what happens, it enable us to measure that parameter, to empirically verify that there is positive association between consumption and current income or not. So what we can see, econometric is a tool which enable us to empirically verify the economic laws, business law, even the law which also associated in social sciences as well. In any respective discipline, whatever law exists, with the help of econometrics, what we can do, we can empirically verify it. The relationship of economic theories are usually expressed in mathematical form, okay, that everybody know. If you see the standard textbook of business or economics, what we see that any particular economic law, that is basically expressed in mathematical form, okay, and combined with empirical economics, okay. So how we combine, like in econometrics, what we do, the relationship of economic theories are usually expressed in the mathematical form and combined with empirical economics. The econometric methods are used to obtain the value of parameter, which are essentially the coefficient of the mathematical form of the economic relationship. Okay, this I will tell you when I will give you examples. Okay, the statistical method which help in explaining the economic phenomena are adapted as econometric method. The econometric relationship depict the random behavior of the economic relationship, which are generally not considered in economics and mathematical formulation. Okay, so what we can sum up, that econometrics is a discipline which we use for empirical verification of any economic law. Okay, so what happened, say for example, we talk about consumption function. In consumption function, we have in current income hypothesis, we have two parameter, that is A and B. Okay, and this parameter, so now what will be the job of econometrics? The first job of econometric will be to estimate A and B. Okay, A and B. So what we will do, we will estimate. So here what we will do, we will borrow some technique from statistics, we will borrow some formula from statistics, and what will be that formula? That formula will give us the value of A and B. A and B, okay, and that will be what? Estimator. Any formula by which we get value of parameter, that is called estimate or estimator, and the particular value which we get, that is called estimate. Okay, now what are the steps followed in econometric analysis? So in the econometric analysis, what we do, we start with a statement of theory or hypothesis. Say for example, the consumption function. Consumption function is that current income hypothesis tells that the consumption at period T is a function of income at period T, and there is positive association between CT and YT. Okay, what we can do, mathematical specification of the model. What we can do, we can give mathematical specification to the model. And how we can give mathematical specification? We can write CT equal to A plus B YT. Okay, that is mathematical specification. And what is the difference between econometric specification and mathematical specification? Mathematical, like all mathematical models are deterministic. Deterministic means that there is no random component is attached to it. Okay, so non-randomness make it deterministic. If you start with LHS, you will get RHS. LHS will be equal to RHS. Okay, but in econometric model, there is a random component associated with it. Okay, so what happens, what we do, we add error term into it. And what is error term? Error term is that, say for example, if we talk about consumption function, in consumption function, Keynesian theory says that consumption at particular period T, like at particular period T, will be function of its current income. But we know in our daily life, it is not only the income of a person, but apart from that, like prices of, there are many things, like taste, preferences, prices of things, many things. which have impact on the consumption. So what we do in economic theory, whenever like any economic theory comes, it believes that the independent variable which is proposed, like say for example in this case, again echo is coming, sound is coming. Hello.
Yes, sir. Yes, sir.
Okay.
So
anybody's talking or what? Okay. Okay. If anybody mic is on, please like what we call switch off your mic. Okay. So what we do, we start with we know that mathematical model is deterministic, and we know it is not only the current income, but apart from current income, there are many other things which have impact on the consumption behavior of like an individual. So what we do, we introduce a error term which is called error, and we say that the whatever unobservable component in the model which we have not included in the model, it will be taken care by the error term. Okay, so we will introduce a error term. Okay, and what is the error term? It is the variable, it is the additional variable which take care of all the ignorances in our analysis. Say for example, in the current case, in the case of consumption function, we believe that only current income have impact on the current consumption. But apart from that, if there is impact of other economic variable, that will be taken care by the error term. And in econometric analysis, we assume that the impact of the unobservable component or the error term will be very minimum. Okay, so means that most of the variation in the consumption will be explained by the income, not by the error. If error will explain major variation in the consumption, the current consumption, then what will happen? There will be a statistical problem in the model, which is known as specification bias, which I will tell you later. Okay. So first what we do, we start with a theory, economic theory, or we build a hypothesis. Then what we do, we give a mathematical specification to the model. In the third step, we give econometric specification. In the econometric specification, we introduce a extra term which is called error term. Error term is what? It is substitute for the ignorances in our model, like which we have not included in our model, but there is a condition that whatever like ignorances we have done in the model, that should be minimum. Okay, so there should be more information in the model and less noise in the model. Okay, if major variation in consumption will be explained by the income, there will be more signal, and if major variation in the consumption will be explained by either error, there will be more noise. So what is our objective? There should be more signal, less noise. Now, the fourth step is collection of data. Then what we do, whatever mathematical model we have built, whatever econometric specification we have given, that we need to verify, and that we need to verify by empirical data. Say for example, in business, many people like they do field survey. In economics also they do field survey, and they collect data and they try to like examine the hypothesis which they have built, that is true or not. And the fifth like stage is estimation of the econometric model. Okay, as I have told you, estimation of like parameter, like estimation of parameter, it is same as estimation of the econometric model. In the estimation of econometric model, what we do, we choose the technique, we choose the formula by which we measure the parameter of econometric model. Whatever alpha, beta, whatever A, B we have got, we try to measure with the help of econometric model. Okay, we search the formula by which we get alpha and beta, and as I have told you earlier in the overview of statistics, that what will be the good formula, what will be the bad formula, best formula, which will follow the property of linearity, unbiasedness, minimum variance, blue consistency, etc. Okay. And then what we will do, whatever parameter, whatever model we have estimated, that we will verify with the help of statistical inference, because estimation of the econometric model will again give us only a point estimate, and this point estimate need to be verified with the interval estimate. Okay, so in hypothesis testing, what we'll do, we will build a confidence interval, and we will try to see that whatever point estimate we have calculated, it falls in the certain range or not. Okay, and finally at the last stage, what we will do, when our model is estimated, when it passes statistical test, I think someone mic is on. Okay,
I
okay.
muted, sir. I muted them.
Okay,
Right.
okay. Finally, what happens if our point estimate passes test in the statistical inference, we go for model use of model for policy purposes, like for policy purposes and for whatever use we have started. So this is all about econometric analysis, like the stages which we follow in econometric analysis. We start with the statement or theory, then we give mathematical specification to the model, then econometric specification, we collect data, we estimate model, we go for hypothesis testing, and finally we use the model for policy purposes. If we sum up all these three stages, what we do, we find that the major aim of the econometric analysis is threefold. What is that? First, formulation and specification of econometric model. The first thing, what is formulation? The second thing is that estimation and testing of model, and third is use of the model. Okay, so these are three major thing is done in the econometric analysis, that we go for formulation and specification of econometric model, then we estimate and test model, and then we use the model for policy purposes. Okay, now there I have talked about the nature. Now based on the frequency, there are based on the frequency, following are the types of data used in the estimation of model. Okay, so what happens in econometric analysis, based on the frequency, following types of data basically we encounter. That is, the first category is time series data, okay, which you might have heard. And what is time series data? Time series data give information about the numerical value of variable from period to period are collected over time. Okay, so any data which gives you information over the period of time. Okay, over the period of time, say for example, if you have a data of a GDP of a country, say for example, if you have a GDP data of India from 1990 to 2010, so that data is a time series data, because in this case what happens, you have a over the period of time. Okay, and this is a annual frequency. Okay, so any data which is over the period of time is called time series data. It can be monthly, it can be quarterly, it can be weekly, it can be daily, or it can be yearly. Okay, so in this case, what is necessary condition, that you should have a data over the period of time. Now second, cross section data. What is cross section data? The cross section data give information on the variable concerned individual agent given point of time. Okay, so in cross section what happens, you get data at particular point in time. Okay, point of time. Say for example, you might have heard about the NSSO data, National Sample Survey Organization data. So say for example, we talk about 68th round of data. So what happens in NSSO, in the 68th round, the data is about 2011 and 12 data for say 60,000 household. Okay, so that data is for 60,000 household, at that particular year. Okay, so this is this is cross section data. Cross section is data is collected at particular point of time. Even the survey, the field survey which you do, if you go to field and you do field survey, that data is also what? Cross section data. Okay, and there are example of that. Now panel data. Panel data are the data from a repeated survey of single sample in different period of time. Okay, say for example, if there is a cross section, okay, at a particular point in time, if at a particular point in time, if at a particular point in time, if you collect a data, and if that data, say for example, sorry, if at a particular point in time, if you survey a cross section, okay, if you survey a cross section and the sample, if the same cross section means, say for example, if at a particular point in time, if you survey and if you collect data for a 60,000 individual, okay, and again if you survey a data and again you collect data in the next period of the same 60,000 individual, then what will happen? You are repeating the same cross section. If the same cross section is repeated over the period of time, then that type of data will be called panel data. Okay, and what is the example? Say for example, that was about individual. Let's talk about the country. Say for example, there is a BRICS country. Okay, BRICS country: Brazil, Russia, India, China, and South Africa. If you collect data on its GDP and this gross domestic capital formation from 2090 to 2018, okay, so what happens? You are repeating the same country, okay, and you are also repeating the same year. So here country is a cross section and year is time period. So what happens? You are repeating the data for same cross section over the period of time, and such kind of data is called panel data. Okay, and based upon the nature of data, different econometric tools and technique is also applied. Finally, there is a dummy variable data. Okay, dummy variable data is that the above data which we were all the three category, like either it may be time series, cross section, or panel. All these three category of data are quantitative data. They are that can be quantified, but quantitative data, or it is measured in number. Okay, now in case of dummy variable, there is a other kind of data, qualitative data, which is called dummy variable data. Say for example, if you want to know the caste of somebody's gender, say, if with the help of gender you want to know the salary of anybody, everybody know, like it is a very famous example that in jobs what happens, there is discrimination and females are paid less as compared to males. Okay, say for example, if you go to paddy fields, so what you will find that male workers are paid more than female workers. Okay, discrimination, caste discrimination, that also, it is a qualitative variable. So in such case, what we can do, we can introduce dummy variable. And dummy variable is what? It is a qualitative in nature, and it is again a substitute for ignorance. Okay, it measure a quality. So presence and absence. Okay, say for example, in 1991 there was an economic reform. Okay, so that whether post 1991 there was impact of economic reforms or not, that can be measured with the help of what? That can be measured with the help of dummy variable, this qualitative data. Okay, hope you all are comfortable with it, dummy variable. Okay, and it takes value 0 and 1. Okay, if there is no impact or control, it will take 0 value, and if there is any change, reformation, for that it will take value 1. I will clear all this with the help of example. Okay, so now what are the major econometric tools and techniques which are these are not only limited to it. There are many techniques, but some of them I have written here, that the widely used econometric technique is regression analysis. Regression qualitative response models, okay, like logit, probit, tobit, LPM. These are called qualitative response models. Then simultaneous equation model, panel data model, co-integration, vector auto-regression, ARMA. Okay. So what is regression analysis? Regression analysis, I will tell you in detail. Qualitative response model. In qualitative response model, say for example, on the left-hand side, if your dependent variable is a qualitative, which takes value 0 and 1, which takes value quality, okay, on the basis of quantitative information. If you want to know that a person is black or white, if you want to know a person is male or female, okay, if you want to know, any impact, qualitative impact based upon the quantitative information, so in that case what you will do, we will take help of the qualitative response model. And there are four major kind of qualitative response model, that is linear probability model, LPM. Then we have logit model, we have probit model. Now, simultaneous equation model. So all single equation model, regression analysis, QR model, these are limited information method. Okay, but on the other hand, simultaneous equation model, it build a system. Okay, it start with structural equation, then it comes to reduced form equation, and with the help of system, it try to give solution to the problem of simultaneity. So that is why it is called full information method. Then panel data model. So whatever model this year here we are talking of, these are basically applied majorly on time series data. But if the data is panel, so in panel data, a special kind of model we are using in panel data, and that is called pooled regression. We have least square dummy variable method, which is also known as fixed effect model, random effect model. Then we have system GMM. So such kind of model we use in panel data. Okay. Then we have ARDL also, autoregressive distributed lag model. Okay. Then other time series technique is co-integration analysis. Other time series technique is vector autoregression, ARMA, that is called autoregressive moving average method, ARIMA, autoregressive integrated moving average method. Here I will tell you about three kind of method, that is regression analysis, qualitative response model, and co-integration. Okay, so my major focus will be on this three kind of model. Okay, so what is regression analysis? Regression analysis, it is linear relationship between the conditional mean of y dependent variable with the fixed value of x independent variable. Okay, so what happens, say for example, if we talk about the consumption function, so what we do with the fixed value of income, okay, what we will do, we will try to know what will be the average consumption. So again, you can see it is a conditional mean of y dependent variable with the fixed value of x independent variable. So regression analysis, what it tells about the average association between dependent and independent variable. In consumption function, dependent variable is consumption and independent variable is income. So if in any society, if the income is fixed, say for example, if in a society the income of people is 10,000 per month, what will be the average consumption? Okay, so here the value of income is fixed. That is why with the help of fixed value of income, we try to measure the conditional mean of consumption. What will be the conditional consumption if the income is fixed at 10,000? Okay, so at 10,000, what will happen? We will have a distribution. Okay, distribution, and at that particular distribution, we will see that what will be the mean consumption. Okay. On the other hand, what is correlation? Correlation, it is the linear association between the two variables. Okay, say for example, we have a x variable, y variable, and in our case, x is income and y is consumption. So it will be it tell about linear association. Okay, it tells the degree of association. Okay, how both the data is fitted with each other. But In case of correlation, it will not tell about which is the cause and which is the effect. Okay, so there is a positive linear degree of association, but correlation coefficient won't tell us which is the cause and which is the effect. But in case of regression analysis, we have clear idea about what is dependent variable and what is independent variable. Now, coming to population regression function, as I told you, in statistics, we have population and we have sample. Okay. So likewise, in regression analysis also, we have population regression function and its sample counterpart is sample regression function. Okay. So for what is for population regression function? Population regression function tells about the true relationship between dependent and independent variable and whatever the true parameter is associated in the population regression function. Okay, so I'm reading it definition. It is a linear function which hypothesizes a theoretical relationship between dependent variable and a set of independent variable at a population level. Okay, so if at a population level, say for example, if I have to estimate a consumption function, okay, of this, say for example, I am living in Varanasi, and if in Varanasi I want to estimate a consumption function. So what is, like what I can do? First, I can, like go for census. I can go to every household of Varanasi and I can ask, I can gather information about their consumption and income, and we can arrive at, like estimate. Okay. And that estimate will be population estimate. But in reality, we know that going for census is not possible. Okay. So in that case, what we will do? We will take help of the sample, and with the help of sample, what we will do? We will try to infer about the population parameter. Okay, population regression function will be having parameter, and we will try to infer a population parameter with the help of sample. Okay, so likewise, the same sample regression function, it is a sample counterpart of population regression function, which is also a linear function which hypothesizes a theoretical relationship between dependent and a set of independent variable at sample level. Okay, so it tell about at the sample level. Okay, it is the sample counterpart. Okay, and like sample characteristics, we understand with the help of sample statistic, and population characteristics we understand with the help of population parameter. What it implies? It implies that at population, the word parameter will be always used for population, and the word statistic will be always used for sample. Okay. Now, what is ordinary least square? Ordinary least square. Now here in regression analysis, the most widely used technique which is applied in regression analysis is OLS. That is also known as ordinary least square. Okay. So we know the regression, that is, we know regression. What is regression? It is average association between X and Y. Okay. X independent variable and Y dependent variable. Okay. And I also told you that what will be the value of X independent variable with the help of, what will be the value of Y independent variable if there is a fixed value of X independent variable. Okay. Now, as I told you, the parameter of consumption function, whether it is A or B, the parameter that we need to calculate. Okay. And that we will calculate with the help of some estimator. And that estimator will give us an estimate, which estimate we will again check in the interval. We will derive an interval estimate, and we will see that whatever point estimate we have estimated, that fall in that particular statistical range or not. Okay. So what is ordinary least square? Ordinary least square is also a way or a method by which we can get estimate of regression function. Okay, the basic idea behind OLS is choosing stochastic regression function in such a manner that the difference between actual and estimated value of dependent variable should be minimum. Okay, so what is actual value? Actual value is whatever population will have. Okay, so what happens? We are choosing what? We are choosing sample, and with the help of sample we are trying to infer about population, and we know all sample is not free from sampling fluctuation. and because of sampling fluctuation, it is possible that the value of parameter, the value of whatever sample statistic which we will get, because of which the value of our sample counterpart can be different from the population counterpart. So OLS is a method by which we derive parameters, parameter of population regression function in such a way that the difference between actual and estimated should be minimal. Okay, so this is the idea behind it. Now, what are the assumptions? The first assumption is that model should be linear in parameter. Okay, the model should be linear. There also I told you, in case of overview of statistics, any good estimator should also follow the property of linearity. What is linearity? That estimator should be linear function of sample observation. Okay, so whatever sample observation is, it should be linear function of its parameter. Okay, so here, but in case of ordinary least square, here linearity is said in terms of parameter. Okay, the second assumption is that the value of x are fixed in repeated sample. Okay, so value of x is fixed means that, say for example, whatever independent variable you have, that should be fixed. Say for example, if we are estimating a consumption function, we have the data of income, and that income data is not random because that income data is already with us, and with the help of that income data we are trying to measure the conditional mean of consumption. Okay, so the second assumption is that our independent variable should be non-random. It's because if it will be not fixed, so what will happen? It will become random, and this random variable will again correlated with our error term, which is UT. Third assumption is zero mean value of the disturbance. Whatever error term, disturbance terms we have included in our model, that should have zero mean. Say for example, zero means that positive error and negative error should cancel out, and the average impact of unobservable component should be negligible or zero. Here it is zero. Okay. Fourth is homoscedasticity. Homoscedasticity means, say for example, homoscedasticity means that your variances of error should be constant for every value of x. Say for example, if we are measuring a consumption function, and at 10,000 income we have got some average consumption. Okay, so for that particular distribution we will have some error, that is variance. And if we go from 10,000 to 20,000 income level, there also we will get a distribution. So here the assumption is the error variance of this distribution should be constant irrespective of the value of x. Whether your income changes from 10,000 to 20,000, 30,000, 40,000, 50,000, 1 lakh, whatever it may be, but the error variance should be constant. When the error variance will be constant, that case is called homoscedasticity. Okay, so it is required in case of this OLS. The fifth assumption is no autocorrelation, that our error term UT, it should be not correlated with the error of the immediate past or immediate past. So what will happen? If it will be correlated, then we can't say that the sample is independent. Okay, so sample independence is very important. Now, number of observations should be greater than the number of parameters. So in case of consumption function, so there are two parameters, alpha and beta, that is A and B. So your observation should be greater than that. There should be variability in the x. Okay, so x should be not fixed. Okay, the value of x should be changing. There should be change in the value of x. So there should be variability. The next assumption is there should be no multicollinearity. The independent variable should be not correlated with each other. And final, there is no specification bias. Okay, specification bias means that the correct functional form should be included in the mathematical formulation of the model. Not any important variable is left out in the analysis. It is prerequisite for it. Okay. So this 9 major assumption we have in regression analysis. Okay. So now, if you go with this, what you will find that your whatever like parameters you will obtain with the help of OLS, this parameter will follow linear unbiased minimum variance and blue property. Okay, this property it will follow. So as I told you earlier, you can see here, in case of statistics, a good estimator like follow this much property: linear unbiasedness, minimum variance, efficiency, blue, and consistency. And here also in case of OLS we see that it follow majority of that property. So we can say OLS estimator is a good estimator. Okay, now there could be possibility that there can be violation of some property like multicollinearity, heteroscedasticity, autocorrelation, and in that case what will happen, we will face problem like estimation problem, which is mentioned here, and that you can what we call also understand by any standard test books. Okay, now coming to qualitative response model. So the earlier regression analysis which I was telling you, that was in case when both independent and dependent variable both are quantitative. But say for example, in case if the dependent variable, your y, is qualitative, okay, and it is a dummy variable. And what is dummy variable? A dummy variable is a qualitative or categorical variable which more often takes value 0 and 1. If a dummy variable takes value, it takes 2 category, then we give value 0 and 1, and we also call it binary variable. 0 we take for control and 1 we take for change. Okay, this I will explain you in example, when I will tell you about example, there I will explain. It is also called attribute and substitute for ignorance. So this dummy variable is also called attribute and substitute for ignorance. In general, there are 4 approaches to binary response regression model. Okay, the first approach is linear probability model. The second approach is logic. Third approach is probit, and fourth approach is tobit. Okay, so here what I will do, I will tell you about LPM, logic, and probit. So what is logic? Linear probability. Sorry, LPM. A linear probability model in which we model conditional probability of dependent variable on the fixed values of independent variable is called linear probability model. So what we do in case of linear probability model, we repeat same regression analysis thing in this case also, but only difference is that in regression analysis the dependent variable we had that was quantitative, here we have qualitative. Okay, so but because of qualitative dependent variable, we face many problems. Okay, and what those problems are? The disturbance term, the UT, this is no longer normal. This is no longer normal, and that is because of Bernoulli distribution and other thing, which you can know by the standard textbook of econometrics like Gujarati and Wooldridge and all. Now again, the other what drawback we find here, there is heteroscedasticity. Again, it is because of Bernoulli distribution. Then possibility of y lying outside the range. Okay, as we know that probability, as we know about the probability should always lie between 0 and 1. Okay, but when we go for linear probability model, in that case there is possibility that the probability of yi can fall beyond the range of 0 and 1. Okay, and low value of r square because of no scatteredness in the data. Okay, and the fourth problem which we get, that r square value, the goodness of fit value, it is also very low, and it is because of low scatteredness, because the dependent variable takes value only 0 and 1, it fall on only 2 points, and it follow Bernoulli distribution, and because of that we get low r square value. And the solution of it, as I told you, that in case of LPM, there was a chance that the probability of yi can go beyond 0 and 1. So this problem can be fixed by two methods, that is logit and probit. In logit and probit, what happens? We can use a S-shaped CDF. CDF is cumulative density function that I have not told you. Like this also you can like see in a standard textbook of econometrics or statistics. So which restrict the value of the probability of value of yi to lie between 0 1. Okay, when we use like logistic CDF, then the model is called logit, and in case when we use normal CDF, then the model is called probit. This is the only difference between logit model and probit model. In any interview, if somebody will ask that what is the difference between logit model and probit model, so both are based on S-shaped cumulative density function, but in case of logit model there is logistic CDF, and in case of probit model there is a normal CDF. Okay, so this is the only difference. Now coming to the co-integration analysis. So what is co-integration analysis? It is given by Angel and Granger. So co-integration analysis, it says, like the basic idea behind the co-integration analysis is that it says that in co-integration analysis, if there is any economic theory, okay, and if that econometric theory should hold, okay, so what happens if that is true? So in that case, what happens that we know that economics, that there can be deviation from the equilibrium, okay, in economics, okay, but this deviation is a temporary phenomenon. And if the theory is true, there should be long run equilibrium between among the like variable. Okay, so what is point is that co-integration analysis is based upon the idea that the whatever deviation from the equilibrium is a temporary phenomena, okay, and that deviation could be in the short run, but in the long run there will be always equilibrium relationship exist. Okay, so there will be always equilibrium relationship in the long run. Okay, so that we see. So what we do, we start with a testing stationarity of variable, and that stationarity we test with the help of unit root. Then we go for co-integration test. This unit root test can be done with the help of Dickey-Fuller test, ADF test, Phillips-Perrin test. There are many tests, Then we go for co-integration. Co-integration can be also done with the help of cow test, Johansson-Julius test. Okay, there are many tests. And then what we can do, we can go for short-run diagnostic test. We can also derive long-run equation, and we can see with the help of error correction model, we can see the speed of adjustment at which this model is corrected. Okay. Now, finally coming to the examples. Okay. So far, like what happened in econometrics, I have told you about what is all about econometrics. It is basically empirical verification of economic laws. Okay. And here what we do, we borrow some tools from mathematical statistics to basically estimate parameters of economic models. Okay, so what we do, mathematical model, from mathematical model, what we do, we go for econometric model, and in this econometric model, what we do, we take help of mathematical statistics and we derive parameter of it. Okay. And then what we do, we go for hypothesis testing, and I have like three major tools of econometric analysis. I have told you the first one was regression analysis, and in regression analysis I told you that how with the help of OLS, ordinary least square method, we can derive the parameter of any model. Okay, regression model. Then I have told you about qualitative response model. If the dependent variable is qualitative, in that case, how you can use LPM, how you can like apply LPM, and the drawback of LPM, how you can fix with the help of logit and probit. Okay, and finally I have told you about one of the widely used time series technique, that is co-integration. Okay, So I know, like in a very short span of time, I have covered many things, and many of you people might have, faced difficulty in understanding all this thing. But due to constraint of time, I can't do much. Okay, so I can only beg pardon from you people on that thing. Okay, now coming to what we call examples. Okay, so first of all, I will start with the OLS. What is OLS? I will start with OLS. Okay. Can you see this screen is visible to you people? Dr. Upendar, it is visible?
Yes, sir, it is visible, sir.
It is visible. Okay. So now I will tell you that OLS estimation procedure, like in EVUs using time series data. How you can use time series data to estimate, regression model with the help of OLS estimation technique. Okay. So here we have started with hypothesis economic theory, and that economic theory is whether financial development, it is visible, or I should enlarge it. Okay, I should enlarge it. Okay, now here the economic theory is whether financial development positively contribute to economic growth or not. Okay, so there are many finance people, and there is economic theory that financial development, financial inclusion have positive impact on economic growth. And there are many theories, there are many literature which support this argument, and that is Schumpeter 2000. This is not 2000, it is 1911, not 2011, it is 1911. 1911, in Schumpeter in 1911 wrote a book called Theory of Economic Development. In that he talked about the importance of financial development in the economic development of any country. Then there is a financial repression theory was given by McKinnon and Shaw, and subsequently there are many literature, substantial amount of literature is developed. So here, what we want to do, we want to check whether, there is positive impact of financial development on economic development or not. Okay, so with all limitation in economics, more often we take economic growth as a proxy for economic development. So here also what we have done, we have taken economic growth as a dependent variable and proxy for economic development, and we have taken financial development as a independent variable, and also we have taken some control variable. Why control variable? Because we know that it is not only the financial development, but apart from financial development, there are also the other variable which also have impact on economic growth. Okay. So what we have done, the above relationship implies economic growth is a function of financial development and other control variable. In this model, in a production function, apart from financial development, there is also other determinants of economic growth. So what we have done, we have given econometric specification to this model. So here, if you can see in this equation, what happened here, per GDP, per capita GDP, I have taken as a proxy for economic growth, broad money as a share of GDP, and domestic credit as a, domestic credit as a share of GDP, I have taken as a proxy for financial development, and market capitalization as a share of GDP. This also I have taken as a proxy for financial development. Trade openness, wholesale price index, this I have taken as a control variable in the model. And D1 I have taken as a dummy variable. This dummy variable is what? It is a substitute for ignorance. It is for to incorporate qualitative change, like if anything happened in that particular time. Okay, so here what I have assumed that post 1991 there was some economic reform started in Indian economy, whether there was impact of that structural reforms on Indian economy or not. And everybody know there will be having some impact of structural reforms on economic growth. Okay, so I have taken this also. So what I have done, before reform period I have assigned the value 0, and after reform period I have assigned the value 1. Okay, so 0 is called control period, in which there was no change, and 1 is for structural change. Okay, 1991 onwards. Okay, for structural change we use 1, and for control we use 0. Okay, then what we do, we estimate this in various steps in e-views. This is a screenshot, like I have like made, like how you will go on e-views and how you can estimate it. If you want, I can share this with Upendar ji. He will share with you people, like how you can do all these things. Okay.
Yeah, sure, sir. Okay, sir.
So now what happens, after giving specification, just a minute. Okay, yeah, it's going down. Finally, what happens, you get this kind of output table. Okay, this kind of output table you will get. Okay, so here you can see from e-views, here you can see dependent variable is per capita GDP, and these are independent variable. C is constant. C is a constant. Okay, and broad money as a share of GDP is an independent variable. Domestic credit as a share of GDP is an independent variable. Market capitalization as a share of GDP, it is also independent variable. Trade openness as a share of GDP, it is a control variable. Wholesale price index, it is also a control variable. And D1 is a dummy. Okay, there is a dummy. So here we can see. Hello.
Sir, I can mute them.
Okay. Some voice is coming, I guess.
Yes, sir. I will mute, sir. I'm finding.
Okay.
I'm finding it.
Hello. Okay.
Yes, sir. I'm finding.
Okay.
Simple.
Unable to find.
Not able to find. Okay.
உள்ள வரணும்னா அந்த மேல நம்ம சர்ச் பண்ற சர்ச் பண்ணல, அந்த மேல ஒரு இது கூகுள் ஏதாவது அடிக்கணும்னா சர்ச் பண்ணுவோம் பாருங்க. அதுல சர்ச் பண்றதுல மேல ஃபீட்பேக் அது இதுன்னு இருக்கும். அதுல இருக்கோன்னு இங்க ஓபன் ஆகன உடனே அதுல மேல வச்சு ஒரு அமுக்குன உடனே எனக்கு ஃபுல்லா காப்பி ஆயிடும். காப்பி ஆகி காப்பி ஷேர் பேஸ்ட்னு கேட்க, நீங்க காப்பி பண்ணி வச்சுக்கிட்டு அதுல ஓபன் ஆயிருக்கும், அதை ஃபீட்பேக் திரும்ப அது காப்பி நம்ம கையில இருக்கும். வெளில இப்ப என் வாட்ஸ்அப்ல போய் என் இதுல போய் ஆச்சு ஒரு அம்மா எல்லாம்
Yes, sir. Just now I found that. Yeah, I found that.
இப்ப நீங்க இது வந்திருக்கீங்களா தலைவரை? இப்ப நீங்க அனுப்புனீங்களா?
Muted.
Wait. Okay, sir. Wait. Yes, sir. Now carry on, sir.
Okay. Thank you very much. Thank you. Great. It's great help,
Okay.
Okay, so here you can see that I have tried to examine the impact of financial development on economic growth. Okay, so here you can see that for financial development, for economic development, I have proxied that economic development with per capita GDP growth, and I have proxied this financial development with two kind of indicator, that is broad money as a share of GDP and domestic credit as a share of GDP. This is financial development indicator, but in particular it is a banking sector development indicator. And the other indicator we have for financial development, that is market capitalization as a share of GDP. It is also a financial development indicator, but it basically takes care of stock market development. Okay, so here what we can see, the first, the second column, it gives like information about the coefficients of the model. Then it gives about like data about the standard error. Okay, then t statistics and probabilities, the respective probability value. Okay, so what it basically tells, that I will explain. So coefficient is about the parameter. Okay, the parameter, it is about the parameter, it is about the estimate parameter which we have estimated, the point estimate which we have got. Okay, so this is the value of point estimate. As I told you, whatever point estimate you get, that you can't generalize directly into the population, you can't use that directly for inferential purposes. First of all, you need to see whether this population, whatever point estimate you have got, that like falls under the interval or not, like that statistical interval. So here in this case, like what kind of probability distribution we have used? We have used T distribution. Okay, so T distribution we have used, and with the help of T distribution, what happens, they have built automatically a confidence interval, and here we can see that this coefficient for broad money as a share of GDP, like it falls under this confidence interval with 1%, level of significance. 1% level of significance means that there is 1% chance of committing error. Here, in this case, we can see domestic credit as a share of GDP. Here, the chance of committing error is 53%. Here, the chance of committing error is 2%. Here, 34%. Here, 99%, and here 1%. In statistics, what we do, standard, we take 5% level of significance. So what we do, we allow that we can go for error up to 55%. Sorry, up to 5%. Okay. So here, what we can say that our this intercept, it is statistically significant. Broad money as a share of GDP coefficient, it is also statistically significant. Market capitalization as a share of GDP, it is also statistically significant. And the value of dummy, it is also statistically significant. Okay, it is also statistically significant. So what we can infer, though it is not complete analysis, but with the help of this, what we can infer, that in India, if we analyze the data between 1988 to 2011, what we find that there is positive impact of financial development on economic growth. But in this case, only banking sector development indicator have banking and stock market indicator. Okay, both have impact, but as compared to stock market indicator, you can see the coefficient of stock market indicator, it is 18 point something. And here the coefficient of broad money as a share of GDP is 239. So what we can conclude, that the impact of banking sector development is more prominent in case of India as compared to stock market. So by this we can say that in India, that banking sector plays a major role as compared to stock market in economic growth. Okay. Now here also we can see that dummy variable in the post-reform period, dummy variable have negative impact on the growth. Okay, so in the so why it can be because of specification bias also. As I told you, this OLS method is not complete in itself, and like they can be having like other problem as well, like the problem of autocorrelation, multicollinearity, heteroscedasticity, and other things. Okay, so here we see that R square is also very high, that 0.99. 99% like variation in the per capita GDP is explained by this variable. So high R square is also sign of multicollinearity. Okay, so here you can see the Durbin-Watson value is 0.9, which give indication of that there is autocorrelation in the model. All these details, that how to detect autocorrelation, all you can find in any standard textbook. For example, you can see Gujarati, Woolrich, or any book. Okay, so this was all about the result. I will share all this PDF with you people, and for detail what you can do, you can read my paper Singh and Mishra 2014. Okay, you can read this paper. This you will find on my what we call Google Scholar profile. Okay, this you can download from there. Okay, now coming to the next example, and that example is basically related to your logit and probit model. Okay, logit and probit model. Here, what I'm going to do, I'm trying to, in finance, you have heard the term of credit risk, what is credit risk? So what is credit risk in any financial transaction? What will be the probability that a counterparty willingly or unwillingly will not follow its contractual obligation? Okay, so for example, if a bank have lent money to a company, whether that company either willingly or unwillingly will not follow its contractual obligation, or it will default on its, whatever contract they have made. Okay, so now here again, there is my paper, re-estimation and comparison of alternative accounting based bankruptcy prediction model for Indian companies. This also you can find on Google Scholar. Okay, so here what is the major question? The question is that bankrupt.
Excuse me, sir. Bhanu, sir.
Yeah.
Many participants are posing questions. As soon as you finish the presentation, you give the answer, sir.
Okay.
As soon as possible, finish the presentation and give the answer.
Okay. No problem. So here, what we can do. Here, what you can do. This one I will finish just here. The question is that how to measure a default. Okay, so default is that default is again a qualitative variable, qualitative, incident. Somebody will default or not default. So if a company defaults, for that we take value 1. If it doesn't default, we take value 0. So here what we do, we calculate a probability to default, and for that we take help of the logit model and probit model. Okay, so here in this case, re-estimation and comparison of alternative accounting based bankruptcy prediction model, I have done, I have started with if you go in accounting research, so for leverage, liquidity, profitability and turnover, I have started with 25 ratios. Then in the first step, I have done analysis on ratio. Then with the help of stepwise regression, I have forward selection and backward elimination method I have applied, and I have choose, finally I have got this 4 variable, and with the help of that, I have estimated model, and I have done my exercises, and I have applied logit and probit model to estimate bankruptcy, and my model outperform other model, and in my model I have used logit model. Okay, thank you very much. I have one more example. So we are running short of time, there are many questions, so what we can do, I can share all my example file with Upendar ji. He will share with you people. I thank you all people for patiently listening me. I know it is very painful exercise to listen someone for a longer period of time, or especially on your computer. Thank you very much, Dr. Upendar. Now floor is open.
Sir, there are many questions, participants. There are many questions are there. We will try to give answers.
Thank you so much, sir. Very informative and beneficial for all the participants over here. You made a very complex issue into simple one, and made us to understand in an easy manner. With eminent examples, I could like to say that we are blessed to have a gigonomous guru of economics with us today. We are really blessed for that, sir. Thank you so much. And I request the participants, if you have any queries, please ask the resource person one after the other. Unmute and ask, please. If any participants having any doubts, please raise your questions to the resource person. I request the participants, you can unmute and ask directly. And most of them shared in the chat box also.
Hello?
Hello, sir. Yeah, you can ask, sir.
Hello?
Yes, sir. Is it heard? It is audible, sir. You can ask.
Sir. Sir, good afternoon. Nice presentation, sir. It is very lengthy. This economics, there is no end actually for teaching it is. So it will take not less than sufficient time is required for to explain all this. But still, I'll ask one question, sir. It's not question, it is only clarity I need. So, do you think that this economics is a specialization subject in graduation? If we introduce the specialization in Bachelor of Arts, so it will help the students, of course, but is there any chance to get students in Telangana region, sir? Because it is too advanced course, so it's not general economics.
No, you have asked very important question that whether we can introduce this econometrics course at the graduation level or not. So,
as a specialization study, right from beginning, BA1, BA2, BA3 is complete econometrics. Do you suggest that to all the universities?
Complete econometrics. I think complete econometrics won't be, right, because at last econometrics is a tool. It's not a subject matter, and it goes, with the subject. So, for example, if you are in a business is, will be at first, then econometrics will come. Say, for example, if I am in economics will come first, then econometrics will come.
I understood, sir. My suggestion to organize Dr.E.Upendar, sir, because outcome of this webinar on economics, sir, because it is if you make a proper presentation to concern authority to all the universities, let it be one complete paper in at least in final year BA, so that people will flourish.
Okay. This is very emerging topics are econometrics. Many students are going to learn the econometrics. Yes, sir. Yes, exactly.
So I think it is. This is only my idea. I'm sharing to you, sir. Kindly you present the certain things because he is a nice speaker, sir. You highlighted many things, sir. I belongs to economics only. But right now in university, people are searching for econometrics specialization. A person where it's very difficult to get a PG. Even in all the college, PG is there in MA economics. One of the paper is economics, but as a PG completed, they did Dept, but they cannot teach economics.
No, what is my point, sir? Here also in Banaras Hindu University, we teach student econometrics at graduation level. But what I feel that if you don't introduce mathematical statistics to them, before going to econometrics, you should also teach them mathematical statistics. After teaching mathematical statistics, you can go to econometrics, and it also depends upon the level of dose you get. Because I have also studied from Banaras Hindu University, but at time, when I was studying, during that time here, it was annual course, sir, not semester wise. It was annual. And that time there was no econometrics, at my time. There was no econometrics. Now econometrics is introduced in BA, but at that time there was no econometrics.
I agree. But if you making a mandatory is always better, I think. At least in future, you will not search for economics specialization people. Let people should come forward with all the subjects, especially econometrics. Because being an economics doctorate, he is not teaching or not handling, he cannot handle this econometrics paper, means what is the use of doctorate in economics?
That's true.
I mean to say, this is practical thing where we are seeing in Hyderabad. We belongs to Telangana state. There are many cities, but particularly they are searching for econometrics, but no one is free. No one is perfect in their subject.
That's true, sir.
So to avoid this type of problem, if you make it, if your outcome is make it in true way, is launching one complete paper in final year, at least in graduation. So that will be good in post-graduation. Post-graduation, they can go for specialization directly.
Yes, sir. Yes.
So, Dr. Upendar, this is your conducting this webinar is excellent topic you have chosen.
Thank you, sir.
So quoting of our resource person name and from his biography, the outcome of this result, kindly write a letter to our authority, Council of Higher Education,
Yeah.
and the Department of Economics from your side. This is good because you are practical man, no? Outcome is there.
Yes, sir.
Okay.
Yes, sir.
Hello.
Dear participants, we will share
Hello.
feedback Google chat inbox. Don't be
sir.
Hello.
Any
Hello,
question?
Okay, thank you.
Yes, thank you.
Person
Yeah.
to Upendar.
Yeah, yes,
You're
sir.
welcome.
Thank you. Yes,
You're
sir.
welcome.
Question. Asud, sir.
Sir, sir, I have a question.
Yeah,
Sir,
please,
in
please.
for time series data analysis,
Yeah.
what are the conditions to choose the period of data? Say, for example, find out volatility by using Garch model, by using
Yeah.
stock prices or Sensex.
Yeah.
Then how to select the specific period? Any formula is there to select the period of data?
No. There is no any specific formula, but your period should be sufficient to tell the variation, the volatility which you want to capture. Say, for example, currently there are many people came to me who wanted to capture the volatility in financial, like market, okay, financial market across the country due to COVID-19, due to
Sure.
COVID-19. Okay, and they also wanted to check that whether post announcement of the like economic packages in many countries, like in India it was announced, in US it was announced, in Japan it was announced, and in many countries it was announced. So whether there is any change like in the stock returns, okay, or volatility. So say for example, if you can take 10 days, you can take 20 days, you can take what we call 40 days, 50 days. There is no any specific rule for it, but it should be sufficient. Okay, it should be sufficient. And generally what happens when somebody try to calculate volatility in the time series data, particularly of stocks, they go for very large data period, very large sample period. It's not like what we do in case of what we call our annual data. If you are calculating, and in statistics it is rule that more is always better than less. You might be aware of like central limit theorem. Like if your sample observation will increase, then the value will try to converge to population value. Okay.
Yeah.
So my suggestion is that whatever maximum you get, you take that. That is. And there is no any thumb rule. There is no thumb rule by which you can say that 20, 30, 50, 40, 100. There is no thumb rule.
Yes, sir. Yeah. Any question?
Thank you.
Well, two questions. Father can ask for 2 questions. It's almost 1 more. Any questions?
So what are the components of econometrics?
Yes.
What are the components of econometrics? Components in the sense, can you elaborate? Component in the sense? Branches, in component, what you can see. Based on, in econometrics, what happens, all techniques are basically based upon the type of data. Say, for example, the techniques which is developed for time series data, the same technique you can't apply on panel data, same technique you can't apply on cross-section data, okay? And same technique you can't apply on this qualitative data, okay? You're getting my point. So here my point is that based upon the type of data, based upon the frequency of data, based upon its occurrences, what we have different kind of econometric techniques. For time series, we have like regression analysis, we have simultaneous equation models, we have co-integration technique, we have ARMA, we have vector autoregression. Same technique you can't apply in panel data. In panel data, we go for pooled regression, but we know that there is problem in pooled regression. So because of we go for least square dummy variable model, which is also known as like fixed effect model. Then we have random effect model. And nowadays, if you read like standard econometric papers in journals, you will find there is a like too much use of GMM, generalized method of movements and system GNR. Okay, so it's all depends upon the type of data. Thank you.
Yeah. Yes, madam.
Hello.
Yeah.
Hello.
Sir. Hello.
Sir. Ask question.
Hello.
Good afternoon, sir.
Yes.
Hello.
Good afternoon.
Hello. Yes. Good afternoon, sir.
Can
Good
I
afternoon.
add something?
Yes, sir. This is Zahra. Hello, sir. Yes, sir.
Yeah.
So my
Carry
question
on.
is that I am
Hello.
pursuing PhD and the topic is
Can I
maternity
add
benefit.
something
So I just want
regarding
to
the last
ask.
Okay.
question?
Kanchan Datta, sir. Madam is asking question. After madam,
Hello.
you ask question. Please hold, sir.
Hello.
Yes, madam.
Yes,
Yes.
sir. So I want to ask that how can I measure the positive socio-economic impact of amended maternity benefit act on women?
Okay. So that what you can do for that, you can again apply any of the qualitative response regression model. Okay, QR model only will be applied in your case because maternity benefits, so what is your dependent variable? What is your dependent variable? Madam, any idea what is your dependent variable? Okay. Madam? Okay. So whatever I have understood, what you can do in your case, you can use any qualitative response regression model, and in that you can, do your analysis. Okay. Thank you. Upendar ji. Dr. Upendar, can you hear me? Yeah.
Hello.
Dr. Kanjan Datta.
Yes, sir.
Hello.
Datta, sir.
Hello, sir. Actually,
Yeah.
I want to add regarding the previous question
Yeah.
that what are the components of econometrics? Somebody asked.
Yeah.
Something. So
Yeah.
I want to add that whatever we have learned from starting from microeconomics to macroeconomics, public economics, the theoretical background, whenever we are going to investigate the tests, that rules, that laws, with the help of statistics, with the help of little bit mathematics, so we can take the help of econometrics. So econometrics is nothing but the combination of economic rules, that means economics, statistics, and mathematics.
True, sir. True. Very true, sir.
Yeah. Yes, Swati, madam. Madam.
Yes, sir.
Hello. Yeah. Swati, madam, it's time for the
Okay. Fine, sir. Fine.
Yeah. Okay.
Thank you for everyone for participating over here. Now I would like to.
Swati, madam, one last point I want to make before closing the session.
Yeah.
Whatever PPT I have prepared and whatever example file I have with me, that I will share with Swati madam and Upendar sir, and you can share with the participants. Okay, because I was not able to complete all my examples and slides. And thank you very much, ma'am. Thank you very much, sir.
Madam,
And thank you very much, everyone, for patiently listening.
Yes, sir.
Swati, madam.
Sir,
Swati,
we are
madam.
having our principal over here, sir. Yes,
Yeah.
sir. I would like to invite our honorable principal, sir, to speak.
Yeah, sure.
Please, sir. Dr. T. Srinivas, sir.
A very good afternoon, sir.
Thank you, sir.
A very good afternoon to all the participants and particularly to the today's resource persons. Thank you very much, sir. This is Principal from Mother Theressa College of Engineering and Technology. As parallel webinar is going on by other departments also, I could not join at the beginning. So I sincerely express my heartfelt thanks to resource persons and even all the participants also. So in the present scenario, in this pandemic situation, certainly this type of webinars are very much needed and essential. So without which now we can't educate the needy people, students, and all the researchers also. So once again, I sincerely express my heartful thanks from my colleagues and my management, and particularly from MBA department. I really appreciate MBA department. So this is almost, I think, nearly 78 webinars we have conducted. So Yeah, without these webinars, we can't go ahead also. So total education system is going to change. So once again, I express thank you.
Thank you very much, sir. Thank you very much, sir.
Thank you for joining with us, sir. Thank you a lot. With your support, we are going to do all these things. Thank you so much, sir.
My
And I would
pleasure.
like to invite Tabasum, Tabasum Sultana ma'am from our department to propose the vote of thanks. Please, ma'am.
Thank you, ma'am. Good afternoon to everyone. Uh, Myself, Tabasum Sultana, Assistant Professor from MBA Department. I feel immense pleasure to take this opportunity to propose vote of thanks. I take this opportunity to specially express my deep regards and gratitude to our eminent resource person, Dr. Bhanu Pratap sir, who spares the time from busy schedule to grace this webinar successfully. Heartfelt thanks to our management of Mother Teresa College of Engineering and Technology for always encouraging us and providing opportunities to organize such events. I would further extend heartily thanks to Dr.E.Upendar sir, HOD of MBA Department, Mother Teresa College of Engineering and Technology, for his important role in organizing and coordinating such an event. My deep sense of appreciation and thanks to all the staff and to all the participants who choose to be live with us and attended the webinar with great enthusiasm and made this a successful event. Once again, I thank you all for being with us this afternoon. Have a wonderful day ahead. And a small announcement. On 28th of this month, we are coming with one-day international level webinar on machine learning in finances, present and future scenarios. So we hope you will utilize this opportunity well. Thank you.
Thank you very much. Thank you very much for your all kind gesture and for
Thank you,
inviting.
sir.
Thank you.
Thank you very much.
Thank you. Thank you.
Participants, you can leave. On 28th, we are going to conduct one webinar on machine learning in finance, present and future scenario. If you're interested, you can join. I shared the link in Google chat box. Thank you all. Okay, sir. Bye.
Okay. Bye. Thank you very much. I have already shared the document with Dr. Upendar. You can take from him. Thank you very much. Okay. Have a nice day.
Okay, sir. Thank you, sir. Participants, you can leave now. Swati madam. Hello.
Yes, sir. I'm here.
You and మీరిద్దరు ఉండడం తబసున్నా మేడం మీరు వెయిట్ చేయండి.
Yes, sir. Sure. I'll be there.
You can leave the webinar.
प्रिंसिपल को देखा प्रिंसिपल सर का नाम ही नहीं पूरा ये तो होगा
Swati madam. Hello.
Yes, sir. Yes, sir.
We will meet you later. You can leave it.
Okay, sir. Thank you. Wonderful
Bye,
session, sir.
Bye,
Bye, sir.
bye. Bye. Tabasuna, you can also leave.